Another draft physics video presentation. Comments and such. So Jerry Hall has sent more stuff. Yeah, I don't know. It's just you're just saying, well, there's just no common ground in how people think. I mean, it's almost like we have no language and nothing to communicate with because nothing means anything. There's just no common ground. There's just we're speaking the same language, but we're really not because none of the words mean anything, kind of thing. Just seems like we're lost in that. But anyway, I need to explain this a little bit. By circular reasoning, well, I mean, it certainly should have kind of a definition, but whatever. I meant you are supposed to explain the little parts the bulldozer is made of. No, I'm not. Darwin did not have to explain abiogenesis, okay, to explain that we are a byproduct of evolution. And a theory of physics doesn't have to define creation. It doesn't have to say the universe evolved out of a single little piece of error, and the piece of error multiplied. Blah, 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 blah. It doesn't have to have any such theory. And it would be kind of obnoxious if it even attempted to define such a theory just because it's so distant. There's just so little evidence of origins. Anyway, it's a mechanical system. That can be stated. I mean, you're saying it's not? What are you saying? I mean, it's a mechanical system. You either describe it accurately or inaccurately. Whatever. I don't have to explain elemental bits in the universe. If I say there's something called empty space, and then there's this force stuff that all has something in common, it's moving the speed of light, and it's discrete and tiny, and it moves in straight lines, and that I can draw straight lines from that force stuff into stuff called charge, matter, electrons and protons, and I can explain how that stuff moves when it gets hit by the stuff moving the speed of light. Now, that's all I have to do. I don't have to do any more than that, than just to explain that that's what the universe is made out of. These bits, this elemental stuff. And the elemental stuff has these properties and behaves this way. And that's the obligation, in my opinion, of physics. All right. So going beyond that is just silly. It's a religion. It's not physics. There's no science going further than that. Anyway, in object-oriented programming, which I always hated, but anyway, all you're saying is already, let's just build a bunch of standard functions and then try to make the functions work together. So let's make a bunch of complex things that do simple things, and part of the complexity will be that they don't step on each other, that they don't screw each other's function up. But it really doesn't have anything to do with going from elemental functions, which are just memory locations, and that's it. Mailboxes that say go to another mailbox. Go to, go to, go to, go. That's all programming really is. We would call a bulldozer an abstract object. Well, you would. I wouldn't. I'd call it a pretty simple thing. It's a bit changer. All right, so you have bits, and the bit changer is the bulldozer. Where the bit changer goes, the bits change. So it wouldn't be anything like it. So it's a terrible analogy. There's nothing complex about the bulldozer. It only has two properties. It goes in a straight line, and when it hits something, it pushes it. That's it. Okay, it doesn't do anything else. I mean, I've reduced it to such a simple function, and here you are trying to explain it as if it's a complex function. There's nothing complex about it. All right. It's made of smaller pieces, which are made of even smaller units. A smaller unit, no. It's made of smaller pieces, which are made of even smaller until you get to ones and zeros. No, the point is the bulldozer is the 1 and 0. It is a binary. It is at the very core of the function. You can't get much simpler. I mean, this is just so silly that I have to explain something that only has two properties. It moves in a straight line and moves at the speed of light. force, moves at the speed of force, and when it hits something, it moves it. Sure, I understand it's only a metaphor to describe the push. Yeah, something so damn simple. Okay, again, and I'm arguing that there is anything else. There's no come to me bullshit. There's no I'll seduce you. There's none of that crap. Okay, on the elemental level, they're either you get hit or you don't get hit. And if you get hit by more stuff on one side than the other side, that's the way you end up going to move. I mean, how you can't make it any simpler, and yet he's trying to make it complicated. He's trying on purpose. He's trying to break it by trying to make it more complicated than it is. Just so obvious. But even a push is abstract on a classical level. How is it at all abstract? And I made it as completely as clear as possible. I mean, I took away any ambiguity by explaining exactly what I meant by push. All right? I mean, I drew it on the board. I mean, I could do it again. You only have a couple of choices. There's only you can't create any more complexity. Just like the bit can only have a certain number of bits in it, the byte. It's limited by its definition and its function. I guess I gotta get rid of this temporarily. Yes, I did do that. All right. I should just pause and blah blah blah, but screw it. I shouldn't have to. All right. For some reason, the lighting is not as good as it should be. Yeah, it's pretty dark. Well, we'll just have to live with that, I suppose. I can't do much about it now. I won't do much about it now. That's the better answer. I won't do much about it now. It's just irritating. The cameras change their whatever randomly on me. One of the defects of OBS is I can't keep the cameras to be consistent in their exposure. Anyway, just a minor complaint at the moment. So you have an object. I'm saying the matter has no anything. It doesn't do anything. It is, strictly speaking, just dead weight. It's just a clump. And the simple rule is the clump will move a certain amount when a bit of force moving the speed of light hits it. The speed of light force will be blended into the clump of matter and cause the matter to move at some speed much slower than that speed. Now, it doesn't have to be much slower. Could be half the speed, a quarter of the speed, could be 9/10 of the speed, could be lots of things. But the point is it does degrade the speed. And the pusher, the whole time the matter's moving, is not moving the speed of light anymore. It can only move as fast as the matter's moving. Now that's one explanation for the kinetics of the universe. I mean, I could change that rule. I could say that this bit of force, and the idea would be is that when the force is pushing, if something else hits from the other side, the two things reflect. And now the matter doesn't move anymore until another force starts pushing it, and then another force from the opposite direction stops it from pushing. But that would be the simple conservative description of the kinetic interaction between the force and the matter. Now you could describe it as, okay, it hits and it bounces off immediately, and this thing goes. Well, that doesn't seem very conservative because now you have energy in two directions, so that doesn't really work. And then the other would be that somehow the force hits and now the force is dead forever. Except this thing's moving, the same speed as it would if the force was pushing it, but it's moving some slower speed, and then somehow it can make a new force, to compensate for the one it killed when it stops. So somehow when the force goes this way and hits it while it's rolling, that this force would also be killed, but some new force would be created which compensates for this force, but it doesn't really get you back that force. Well, anyway, I'm just saying, I'm starting to give you the reasons why I've chosen the one I have chosen is because it is more conservative. It does explain, and it certainly explains why matter creates gravity, because matter is using up a little bit of the energy of the force that was moving the speed of light. A little bit of its energy is degraded by pushing an object, and that means if you're pushing more stuff this way, it means the bulldozers going that way, okay, have used up more of their energy. Okay, they have less capacity to move in the universe, and the other side has now more of their soldiers, so to speak, will be able to get deeper into you than these soldiers because you used up the energy going this way. So obviously, if you're standing here, you would realize that, oh, there's less bulldozers coming this way and more bulldozers coming this way. I mean, that's the simple explanation. And so I went over this. This is so rudimentary, so elemental to function, and clearly it doesn't have any magical bits in there. There's no magical substances. I haven't left anything, so undefined that there's no grounding for any kind of understanding because there isn't enough mechanical pieces. Sure, I've given you all the car parts. The universe is a very simple machine at its core, is the whole point, and there's just so much of it that's how it creates all this complexity. But what's happening in the real universe, the small universe, that's the real universe argument. I mean, see, that's where what you really need to do in these comments is premise them with, oh, I get you with the push argument, okay, that push is elemental and simple, and that any kind of pull I create can't be elemental and simple. Okay, maybe you can come up with one, but it won't be as simple as the push. The push has a huge simplicity advantage. And you either say, I agree with that, or I don't. And then when I say something like, well, the small universe is the only universe. Whatever electrons and protons are doing, because they're interacting with forces, whatever that's doing, that creates everything else. So all this big universe, I mean, we think we're in a big universe, but obviously the sun and the planets and the galaxies is a much bigger universe. So whatever it's doing it that way. That elemental universe happened first. That the elemental small universe, that's where all the interactions really happen. That there really aren't any interactions on any other scale than their scale. They're the only players here. There's an original brick. Okay, there's an elemental brick, an elemental grain of sand that all this cement is made out of, if you want to think of it that way. I don't know. If you don't concede that argument, then there really isn't any ground for a conversation, because we don't live in the same universe, and we don't, clearly. I don't see any reasonable way to evade those two facts. Okay, that the small universe is the only universe. That's the one where the real empty space is and where the real electrons are and the real force are. They're the real players. The only players. Alright, well. And push. I mean, if you can't get those two concepts, where's our ground for any kind of rational conversation? Because I can't imagine how it can be any other way. Okay. To get to once. Sure, I understand it's only a metaphor to describe the push, but even a push is abstract on a classical level. So again, I just don't. How do you make it into an abstraction? How do you make that simple idea of something hitting something else and causing the something else to react to the fact that it's being interacted with? How do you make that an abstraction? I don't understand. It basically means a surface pressing against another surface. It doesn't matter. I mean, technically, what the mechanism of the fact that they're exchanging, they're interacting, one is being affected by another. I don't think you have to obsess about what the surfaces are, but okay, fine. And moving it to a different location. They both move to a different location. One of them faster than it was going before, right, which was nothing, and one of them much slower than it was going before. All right. On quantum level, so this is just a small level. So again, this quantum word is just more evasion and distraction. Oh, I have to put the text back, maybe. Yeah, that would be a good idea. Put the text back. On the quantum level, there is no real objects and nothing is actually touching something else. So I'm arguing that no, that's true. Like if you want to think about electrons and protons, they probably never hit each other, because there's force between them and the force bounces back and forth or it gets deflected. But yes, they really don't have opportunity to hit into each other because there's too much other stuff between them. There's too much energy between them for them to actually hit each other. But clearly the force communicates that pressure, and it's a real communication at the speed of light. And all the experiments sort of indicate that that's the function, that this stuff all has to happen at the speed of light, and sometimes that means you'll see systems break down because you start doing things fast enough to break down the capacity of the object to react. Like the sound barrier, for example. All right. Okay. On a quantum level, there's no real objects and nothing is actually touching something else. Well, I'd argue that on the quantum level, on the true smallest scale, the elemental bricks are in fact touching each other. The force does touch the matter. Okay, it's more like an exchange of information. So just silly conversation about this stupid information horse shit. I mean, there's no logical reason to attempt to call all of the interactions that take place in the universe a piece of information, because most of it is useless and undefined. If somebody shows up to your house 15 minutes late, there are a million reasons. Okay, in the realm of possibility, there's a million reasons why they're late. What information do you glean? You glean nothing by the fact that they're late alone. So when something happens in the universe, there's no information. Okay, the whole universe is different because it's 15 minutes late. Something did actually happen. That's why they're 15 minutes late. But that information is in the entire universe. It's spread over so many elements of the universe. It can't possibly mean anything as the word information. Okay, just as your whole stupid collapse of a wave function is ludicrous, if you concede that light is bent by gravity, then you're conceding that it's constantly interacting with every gravitational body in the universe, and therefore it can't ever be uncollapsed, because every single movement it makes is going to be dictated by all of those influences. So where does it have any time to be superimposed? It's always being watched by gravity. Anyway, one electron receives photons from another. Well, again, these are all physics arguments, and so I'm clearly arguing that a photon is a rather large pattern of force. It has a polarization that is of itself is 1,000 atoms across. So it's not very realistic to say an electron receives a photon. No, it's part of the process that creates a photon, but it's not the only process. So clearly there's force between electrons. That's my argument. All the electrons in the universe are always talking to each other, in the sense they're receiving information, in the sense they're receiving reflections from all the other electrons in the universe, because electrons are reflecting energy. And by reflecting it, they're telling somebody else, stay away. The reflections mean go away, and so the more light there is in the electron's universe, the more reason there is to get the hell away. Anyway, which increases its velocity. That's exactly the point. So at least you got that part right. But the fact is the electrons don't interact with complete photons. More than one electron has to create a photon. I'm not even sure why something has velocity. Well, I'm just saying it seems kind of sensible to say it's in the universe already. The energy is there. The movement is in the universe. You don't have to explain why there's stuff in the universe moving to understand that there is stuff in the universe moving. So why is it complicated? Why push it? Why force it to there to be an explanation? You know the movement is tiny and discrete. It's in little tiny packets. Isn't that simple enough? Why do you have to go any further than that? I'm not even sure why something has velocity. If I programmed an electron, I would just give it a value which moves. Well, why would you bother with that? I can give it a value which says it doesn't do anything until it consumes value from the environment. The environment tells it. The electron does the adding. The electron doesn't do the creating. So the electron is just sitting there adding up. How much am I getting hit from that direction? How much am I getting hit from that direction? And then it moves accordingly. It just does the math. It measures the pressure and moves accordingly. Why does it have to be any more complicated than that? That explanation can explain everything we see in experiments. Alright, it moves it in a certain direction. Alright, I would just give it a value which moves it in a certain direction. So again, you're just saying I don't need a cause for the effect? No, that would be silly. So let's, I guess that would be the third thing. You don't understand the concept of cause and effect? I mean, you don't agree that things have to have causes? Well then, yeah, we can't really have a conversation. What's the point? There's no evidence of the uncaused effect, so why should I sit here and waste time on a theory that includes uncaused effects? Alright, the idea that something is pressing against something else is classical. No, it's rational. It's all around us. There's every bit of evidence that's how the universe works. Asteroids have to hit the moon for there to be craters on the moon. It's just a fact, okay? Craters just don't form. They're caused, alright? And the whole universe has every appearance of functioning that way. The big universe is telling you the simplicity of the small universe, right? It's always this in-between thing that gets people confused. But when you try to make a really big building, what does it turn into? A pyramid. It turns into a brick, right? It gets simpler, all right? So when you go big, it gets simpler. That's what the big universe is doing, is simple stuff. All right. The individual bits are talking to each other. The only ones talking, in the sense, is through their reflections. And that's it. What they can reflect to somebody else. They're not creating the energy. The energy is coming to them, and they are readmitting it. So everything has an equilibrium with the universe. And that's it. A certain amount of stuff comes in, a certain amount of stuff goes out. And we can see that even in our own lives. But not pushing anything. Alright, so that's just silly. The idea that something is pressing against something else is classical. Right? So anyway. The individual bits are talking to each other, but not pushing anything. So again, that's just, I don't even know what that means. I can't even make sense out of that. They're moving but not doing anything. Well, then there wouldn't be a universe, would there? See, if I don't have matter in the universe, I don't have a universe, because nothing can happen. Matter is the one changing things. So, I'm leaning towards that the universe is just information. Well, whatever that even means. So, la 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 la, whatever. I mean, really, how do you think somebody can actually make that make any sense? There's no such thing. I mean, like I said, a computer doesn't work because there's no physics. There's physics underlying the creation of the bit, creation of the storage, creation of the pathways. There's a mechanical process. It just doesn't make any sense to say the word information. Whatever. Our perception of reality is a mystery. Well, whatever. I mean, what's so mysterious? We have a brain with a bunch of interconnections, and those interconnections are symbolic in the sense that they can represent a pattern, and we can see the pattern in other things. So we can say something like up, and we have a pattern recognition of what up looks like, and then down looks like, and left looks like, and right looks like. And we can associate these different patterns because they have things in common. And then we can put things in categories and have properties. I mean, there's nothing about that that is incredibly mysterious. Now, understanding it in the sense of being able to comprehend 100 billion neurons and all the connections and all the other chemistry that's, makes us impulsive or gives us some feeling, yeah, that's a little bit difficult to, but it's still it's still understandable as mechanisms. Okay. At least I believe it's more helpful to see it this way. So this helpful part really doesn't have anything to do with my agenda. So, again, we're such on different pathways in life. I'm arguing for a statement describing reality. And I believe these statements have consequences and meaning. And this in no way is some sort of thing like, well, help you do what? Help you draw with your crayons? Help you what? Help you feel better? I mean, help what? The argument is are there enough facts for us to be able to eliminate certain things and include and exclude certain ideas as being practical as a option in terms of what reality is made out of? And you're not paying any attention to that argument. There is no explanation for how an electromagnetic wave. So again, this, I've made it so damn clear. There's no such thing. You can't explain any magnetic portion of a photon. Where's its magnetic portion? There's no such thing. And electric is something that happens in atoms, in conductors. There's no electric anywhere else. So it's just crap words. You throw these words together. And that doesn't mean anything. So you're really just saying a photon. So let's just say a photon. A pattern moving through space. That's what a photon is. It's a pattern, moves through space at the speed of light, and it hits a substance, and that pattern causes an effect. And I'm arguing that the cause of the effect is pretty simple. It gives electrons momentum. Can propagate through nothing. So again, so we're back to the simple domino argument. You say the universe has to be made out of dominoes, and the dominoes can have this property. They can hit, and then they wobble back, and they do all this fancy stuff. And I'm saying, I don't need to do all this domino hitting crap. You just make the domino fly. I don't need it to waste its time knocking each other over. Okay? So that difference is almost doesn't matter. But it certainly does matter when you say something like somehow it's inconceivable to have a flying domino. No, it's not inconceivable. I can imagine it so easily. So what's your problem? To pretend you can't imagine a domino that can actually jump? It doesn't have to waste its time telling all the other dominoes what to do. There's a point A and a point B. The domino just jumps. You're saying you can't imagine that in your head. It's unimaginable. I mean, what a pile of crap. I mean, sure you can. I mean, it's really easy to imagine. So don't pretend we have to believe the universe is made out of stuff that bangs into each other in little tiny ways instead of just banging each other in a big way. Why not just jump the distance? It's superfluous. I don't need, okay? I can create a wave of bullets. Do you think the bullets are dominoes falling? Come on. It's silly. All right, anyway, propagate through nothing. Yes, it can propagate through nothing by just flying through it, just like a bullet flies through everything. Or how gravity can pull. Okay, obviously it doesn't pull, so why do I have to even have that argument? I mean, obviously I don't believe it pulls, so why would I have a conversation about how strange the pull is? Yeah, that's right, it's a silly answer. Okay, when there is nothing to do the pulling. Yes, exactly. So it's one of these things where you can start eliminating certain concepts because you can understand that the elemental universe probably doesn't have features that we can't find in the big universe. And you can't find pull in the big universe. All you can find is inverted pushes. Again, the people want to, tug of war, pulling on the rope. They're not pulling on the rope. They're pushing the rope in that direction. That's what they're clearly doing. They're pushing on the rope. Okay. Between a table and the floor, there is nothing. I don't know what that even means. Still, you know what will happen if you remove the legs. Again, and what does that have to do with it? We know that the table is more denser matter than the air underneath it. But if I make the air underneath the table denser than the table won't go anywhere. So we know why it's moving. It's because it's not as buoyant. But the same gravitational force is pushing the air under the table. Okay, all the air under the table doesn't want to be there. It's being forced there by the same force that forces the table to stick to the earth. So again, bad analogy. I agree that the scientists don't know more about this than the rest of us. Well, that I never said. And I think the rest of you, the scientists are smart assholes. And you, rest of you, are dumb assholes. The only thing you have in common is your assholes, but you don't have anything else in common. I certainly respect smart assholes a hell of a lot more than I respect these dumb assholes who are just talking shit and they haven't looked at any of the experiments, they haven't spent any time to become informed, and they're voicing opinions on creation. That's just fucking obnoxious. When you haven't even read the Bible and you're selling Jesus as the Savior, that sucks. So at least scientists have done some work to have some capacity to understand. Now, they've completely fucked their brain with nonsensical notions and ruined all of that intelligence. But I would never say that. Okay, I would never agree that scientists are as futile as you assholes. Anyway, that their ego often make them pretend as they did. I don't know what that means, but whatever. But the math works. So again, this argument that the math works when I'm completely demonstrated the math doesn't work. It's completely feeble. It doesn't even function. In the two-slit experiment, the math is a catastrophe. In the lensing arguments from space, the math is a catastrophe. They had to invent dark matter because the math is a catastrophe. It's just so annoying to sit there and say the math works. Going to Las Vegas and watching the experiments, right, works. That works, okay? And the fact that they can create a couple of formulas that will explain basic probability to you is not much in the terms of math. But to say any of the other math works is just bullshit, because it doesn't do a damn thing. They have some good equations, don't get me wrong, but the pile that you're talking about, the part that have anything to do with this quantum mechanics, aren't good equations. They're horse shit. They never did anything. Okay. It's only when we try to visualize things. The whole point of math is to formalize. That's the word, formula, right? Is to take it and to break it down to its essential ingredients. Break it down to what you put in the bowl and how you mix it. That's its entire function. And to say that you shouldn't be able to draw that. Of course you should be able to draw that. And that's what they do in the two-slit experiment. You can see that their drawing isn't even related to their own math. You can see where the math fails in the sense that when they draw it, what math says, it doesn't look like what they're claiming it is. Like the waves are in the wrong place, for example. So you can see it. So when you do draw the math, you can see the errors, right? So when I draw the math for the two-slit experiment and I have a distance L, and then all of a sudden I'm going to do a beam. So that's for this thing. I figure out what the pattern is here at distance L. And then I go on a flat screen over here, and I pretend the distance L is still L, when it's obviously can't be the same distance anymore. How can it possibly be the same distance? It's impossible for it to be the same distance. Those kind of simple mistakes. There's no point in you telling me, but the math works. Clearly that can't work. It doesn't work, and they're pretending that somehow, oh, look at how good it works. No, it completely fails. Okay, it doesn't work. Okay, it's only when we try to visualize things that it becomes problematic. No, what becomes problematic is when people say, let's analyze what a million things are doing and then give each thing the same properties in that million to average or something and say everything's doing the same thing. It's like the school of fish argument, right? You can understand the school of fish as this complex thing with lots of different motions going on, or you could just see the blob moving 2 miles an hour and you could just say every fish is moving that way 2 miles an hour, right? That's a simple mistake you can make. So that's all that physics has done, is it's taken a bunch of schools of fish and it's generalized about them and then said, well, what is the average particle doing? Well, there is no such thing as the average particle. There's no such thing as the average fish. So you have to understand, some fish are going 50 miles an hour this way and some are going a half mile an hour that way. They're going all kinds of different things. They're doing all kinds of different things. There's all kinds of variety in what they can do. And it's just like a mistake to think that the outcome can be reduced to that too simple emotion. And that's what they're guilty of. Okay, I'll shut up now. Well, that's not the point for you to shut up. What the point was is for you to concede something. Like, first, the evidence isn't good. There's not like any pile of evidence on the evidence table. We're all ready to convict and say, yes, entanglement is real, and yes, gravity waves are real, and yes, light is bent twice as much as any other physical thing in the universe. I mean, all this crap, these claims of physics, and that they have some big pile of evidence that says you must believe. It only that you cannot be reasonable and doubt any of these claims. All of these claims are preposterously, they're so doubtable. The evidence is so weak. It's just a bare, it's not even an indication, the odor. You can't even tell, it's like an odor, and it's like you can't quite tell whether it's a good or bad odor. There's so little of it. Anyway. So. Yeah, that's enough of that. Yeah, look at that. I got choices here. Close without saving. Yes, we won't save that. Alright, so I guess we'll go back to this. So there's a little bit of this video, the ending. So AB Science does do videos that are just a little bit almost, there's almost like too technical. I don't know how many people can know enough to know what he's saying even, but whatever. So he's analyzing the whatever that sapphire thing is, the electric universe's, nuclear program, whatever you want to call it. They made a machine that tries to create plasmas, and they are going to prove something somehow, with this machine, which just doesn't seem to me to mean anything, but whatever. Certainly not going to prove that the craters on the moon were made by lightning bolts. And instead of like him just arguing why lightning bolt theory is just plain retarded, that there's just absolutely no evidence of a single lightning bolt traveling through any part of space ever, that we've never even filmed any of these lightning bolts. And certainly we've never seen a crater created on any place by a lightning bolt. We have seen craters created by real impacts that we've recorded taking place. So how is this theory at all viable, this lightning bolt theory? I mean, they watched a big giant thing, I don't remember, asteroid, comet, well anyway, one of the two, fly right into Jupiter, make a big thing. But anyway, we watched it happen. It's clearly something that happens in the solar system, this nonsense, and again, we've seen them on Earth. It's just there's no viability for their theory. Well, anyway, so he's critiquing the electric universe's confirmation bias, basically. So he made a big complex argument about how their skewing the results of their experiment by their what they wish to see, rather than actually understanding that they don't have enough evidence to see it. So I can make the same argument with LIGO. You get a simple little pattern, you decide that that means black hole, and you really don't have any reason to believe it, and it's a rare pattern, so you can just keep saying every time it happens, black hole, black hole, black hole crashed, and they don't have really good reason. They just decided on something, and they found it in the data. The data will produce the effect every so often, so you can just every now and then announce that you saw another one of these things that it's not really what you saw. But anyway, so dangerous science is the word, right? I mean, that's the concept here. There's ways of doing science that are careful, and where you can be certain of what your steps you're taking, and be careful about jumping too many steps and jumping to conclusions. These are all things that science should be really careful about, and there's absolutely no evidence that his science is any better than theirs. That they've done just the same thing. Something's broken, they fix it with a God of the gaps answer. They have a little redshift problem, they jump to the conclusion the whole universe is flying apart, when they could just as easily understand that maybe light, when it travels billions of miles, actually does interact with some atoms, and through that scattering process loses a little bit of its frequency, which is a known phenomenon. I mean, we know it happens. Compton scattering, we know it happens. The energy, there's a change in the frequency as a clump of photon interacts with matter. But, no, the simple answer, forget that. We'll go with the strange and bizarre answer, because that's their confirmation bias.
Appears to confirm your hypothesis, as your own biases will run haywire. If you fail to do that, you get struck down during peer review.
Okay, so you get struck down by peer review, there's every evidence that peer review is not necessarily better review. So that's kind of the problem, right? The review should be by somebody who knows better, right? If we had student review, right, like other students review students, well, that wouldn't work, right? Peer review on tests and all kinds of different things, that would really fail, right? It's almost like a democracy failing, right? Because peer review really doesn't work. You really want the bus driven by the bus driver, somebody who knows how to drive. You don't want people who don't know how to drive interjecting at all, right? I mean, you don't do peer review to decide how to fly the plane, right? We don't sit a bunch of people in the passengers will peer review. That won't work. So peer review just fails. But anyway, it's better than nothing. Nothing review.
Even worse, it goes unnoticed during peer review, and it is the community that points out that you have made.
All right, so the community, whatever that is. So again, the community of believers argue about how there's a preposterous direct contradictions in the Bible or something. They didn't fix any of that. The writers didn't fix it. The readers don't fix it. Nobody fixes it. Nobody fixed Benjamin Franklin getting plus and minus wrong. I mean, a simple mistake. No critique against Ben Franklin. It was, a 50-50 shot, and he shot poorly, and you never fixed it. You never fixed it. You just sit there and say, okay, we'll just live with this. We have the wrong answer. We've assigned a wrong sign on things. It really screws everything up, but who cares? We'll leave it broken. So there's no evidence that you fix any of your mistakes. So, for the last 100 years, you're flying around in all this wooey nonsense about, particles can read our mind and all this other nonsense. You're playing in a silly playground full of turds, and you're pretending you're doing good science when it's full of bad science.
A rather trivial error, and that's just embarrassing.
Right, so you made a bunch of trivial errors, and I've shown them. So the two-slit experiment, the foundation of quantum mechanics, the weirdness that created all of this mystique and opportunity for all of this woo traveling, warp woo drive. I pointed out how you totally misinterpreted it. You just made a mess out of it. It's so simple, and I can make the argument for the two source interference and how all those experiments are a pile of crap in the sense that jamming is a simple explanation, and yet you go for the extraordinary explanation. Okay, where was we? I don't remember, so we'll just play some more.
So, with that knowledge, I ask you, did Sapphire really show transmutation?
All right, did Feynman or any of these other people really show detecting photons or detecting electrons? Did they show that the only explanation is wooey nonsense and random gods and all of that crap? Or did they really just show how uncareful they were, how unexact, that they never really even did the experiments, right? They just took the stories and just went with the stories of the experiment. I mean, they didn't even try to say, well, yeah, there's a complex pattern with two slits in light. It's not the same pattern as water. It's, different. And we have to explain those differences. That's sort of an important feature. And is there any evidence of any caution? So they've had 200 years since the Young experiment, 220 years. And there's every evidence that you never cared enough to sit there and actually look at it and see if there are possible explanations besides this wooey nonsense. And we can clearly see that you just didn't care about the details. You had more than a simple pattern to explain, and they ignored it for 200 years. They just kept drawing it wrong, drawing it sloppy, drawing it messy, so they could just hide the fact that they really don't have the evidence. That it just really was, they're doing this Sasquatch thing. They're just pretending that a bear standing upright, if you squint your eyes just right, it can look just like a human. No. But whatever. That's all this is, okay? This is just a fact that they are clearly relying on the fact that they can be ambiguous and mushy and just mush over the details and pretend it all works. And it doesn't. And you're guilty. Just as well as you've proven Sapphire sloppy, I've proven you sloppy.
Or did they fuck up because they don't understand what they are doing?
Yes, exactly. So you do understand what you're doing. So that's the difference, right? You have these principles. There's a thing called redoing an experiment. Well, where have you redone Eddington experiment? Did you do it from space where there's 400 times better resolution? I mean, can you explain to me you have 400 times better resolution and you couldn't be bothered doing an experiment that takes an hour? Maybe. That's if you really take your time and do it carefully. And you think that's good science. You think you've done any better than Sapphire in terms of trying to, say that there's a truth and you didn't really prove it's a truth. So you've just done the same thing. You've taken a tiny piece of evidence, a tiny indication that it might be, and you've turned it into conclusive proof. And it's not there. It's a tenth of a fingerprint. It's not even close to good enough.
Decide. I'm pretty sure what the data shows, but I'm happy.
So I'm pretty sure what the data shows. The data shows that the theory of radio jamming is exactly the same mathematics as your wooey entanglement nonsense, your wooey superposition, your collapsed wave function gibberish. Okay, it's exactly the same mathematics. It works as an explanation, and it's dirt simple. I'm sure of that. I'm sure that the double slit pattern, the complexity of it, the two patterns existing means you have to have more than two sources of interaction. So you have to have more sources to create the complex pattern. I'm sure of it. I'm sure you've made a critical mistake. I'm sure Feynman's video on the subject is absolutely misleading and a piece of garbage because it doesn't really have anything to do with the facts. And you just keep pointing to it. You'll just keep saying it is. You'll keep pointing to simulations that are based on wrong assumptions and tell us that's the way it is. When no, if you actually did the experiment, that's not the way it is. That's not the way it turns out.
to be wrong. And with that, I would like to thank all my patrons who know who they are and how awesome they are. Their names will pop up on the screen.
Amazing.
I've also set up
so there's it's almost got more Patreons than he has subscribers or viewers. Well, viewers anyway. But Jesus, so depressing. So anyway, I don't know if there's anything in here worth reading. He'll complain that some of the Electric Universe guys, I guess, will show up and give him a rag. But I'm sure he'll get a lot more applause. Knock him down. Keep on kicking. Yeah, that was a nice smacking. Yeah. Yeah. But they take no accountability for their flaws in their own silly theories and the flaws in their scientific method, just how grossly underdone it is. Grossly insufficient evidence. All right, so on that subject, this was a funny video. So the Science Asylum guy talks to his wife. Okay, now they sort of pretend that his wife is some sort of regular person. She's a biologist, so clearly she's had lots of exposure to scientific conversations. I'm sure she's watched plenty of documentaries that, the hypey physics and all that stuff. So I'm sure she's quite aware of these concepts. So this was a little bit of play acting, in my opinion. I don't know what biologist wouldn't be kind of keenly interested in physics because, frankly, biology is just a branch of physics. So this part it's just a little fakey.
Thanks to Brilliant for helping support this episode.
Blah, blah, blah.
Hey, crazies. Quantum mechanics is best explained when you can judge your audience in real time. So I thought I'd come at this a different way than usual, by trying to explain it to my wife.
If a person is not experimentally measuring it, then what is a measurement?
Right, so this is just, so right here they start with something just full of horseshit, right? Because that's exactly the point. The whole point is the honest scientist will tell you that any interaction is a measurement. Anything that changes the universe is a measurement. It doesn't have to be seen by somebody. I don't have to write it down. The photon hit me, it bounced off and went somewhere. I don't have to detail any of that for me to be measured. I'm measured just as much as the one. I mean, whether whether the ruler has numbers on it, I don't know how to best explain it. I mean, you don't have to have a human being look at it, the data, okay, the interaction, for the interaction to be just as significant. Okay, the significance of the interaction isn't changed one iota by whether you call it a human measurement. A human measuring that interaction is no different than a non-human interacting. And so then theory goes, well, there's a huge measurement problem because, again, isn't gravity measuring everything? The effects of like gravity waves, right? I mean, we're detecting, okay, a measurement. We're detecting an interaction that took place. They are arguing billions of light years away, long, long ago. And we're measuring it by collecting the information, by detailing it. But the measurement wasn't us measuring. We're just measuring an interaction that took place in the universe. So, I mean, gravity is part of what measures things. Everything is being affected by everything's gravity, theoretically. I mean, to some theoretical amount. The amount that Alpha Centauri right now is gravitationally affecting me, well, maybe in 1 second there's only 50 interactions that take place inside of my entire body that are related to the gravity created by Alpha Centauri. But they're real. The ones that are happening are real for those electrons and protons that are being changed in their orientation based on the fact that they feel a little extra force or a little lack of force coming from Alpha Centauri. But it's happening all the time. There's no place for these photons to travel through space, right? And be free of interaction unless you accept the theory that photons aren't affected by gravity. If they are affected by gravity, then they're being measured by that gravity and they're being bent by it. They're having their direction changed. So they're collapsing their wave function. They can't have a wave function. They can't be They can't go into some superposition state at the slits and then travel all the way to the target without gravity measuring them every single step of the way. So they've already been outed. They can't have it. They can't be in this quantum state anymore. They can't be a wave function anymore. So this is just such a pile of crap. I mean, the premise is it's they can't fix it. It's so broken.
Good question.
You know, with you for a while. I mean, it comes up occasionally when we're talking and whatnot. Quantum mechanics has to do with probabilities and...
So, I mean, he's a physicist, she's a biologist, and they're saying they don't have conversations about their fields. I mean, it's just amazing to me. I don't buy that at all. That sounds almost silly. That just doesn't make any sense, that the thoughts and ideas that you're working on in your brain trying to figure out, that you wouldn't discuss it with somebody else who has some literacy in the subject. That would be exactly the kind of feedback you'd like, is somebody who's, got some of the same general education and should be able to muse you with useful feedback.
things, I don't know, appearing and disappearing.
So she didn't watch his videos either? All these years he's been making these videos, she doesn't even watch his videos? Yeah, I don't really believe that.
And entangling and...
Sure.
I don't know, I think that's...
I think it sounds pretty typical.
Okay.
Basically, the idea is that particles, or at least the behavior of particles, is described by waves. Now,
Yeah, right. So that's the basic idea, and it's fundamentally flawed in the sense that you don't need waves. It's dictated by frequency. Frequency tips electrons out of atoms, okay? It's all about this adding energy to a system or subtracting energy from a system. And it's that simple, and you don't need waves to do it. You just need the concept of frequency. So that's where they've conceptually gone on a wrong road to think that the bits of energy have to be part of some giant collective of ether bits or some other kind of crap, okay, that is in some way reacting as a mass, when that's not what any of the evidence really indicates. So, and there's no point in him saying particles, because this is just, it's just silly. They're not particles. They're stuck being dominoes or something, waving dominoes. So why are you calling those particles?
we don't necessarily mean the waves that you're used to thinking about, like nice wave shapes on water or something. Mm-hmm. It's a little more abstract than that. A wave is just a solution to a wave equation.
Right, and the wave equation isn't really a wave equation. So this is just so funny. I mean, this is exactly the arguments I've been making, that they just talk shit, that they've ruined vocabulary completely, and just for the purpose of propaganda. They want people to think what he just said the opposite of. He's basically saying we want them to think that it's a wave. We want them to believe it's a wave. We want them to think all this kind of stuff, but we know it's not.
We've decided that something like Schrodinger's equation is a wave equation. So even though
Well, yeah, we've decided that we're going to sell it as a wave equation because that fits with the wave interference we're trying to sell in the double slit experiment that is really just scatter interference. And it's really not interference at all. It's just reconstruction of a photon, which is demonstrated by the polarizing film. So, again, you can just show how this is just convoluted, mushy language used to disguise the truth, to distort the vision, to make it cloudy and foggy rather than clear and precise. So it's just the exact opposite of science. Science is about clear and precise. They're about fog and mist. I mean, it's smoke and mirrors on purpose. They're overtly stating this is what our physics does, is talk, smoke, and mirrors. It believes something else, but it talks smoke and mirrors.
There are solutions to it that don't look like traditional waves. We call them waves anyway.
You kind of do this in physics, where like...
Yeah, we call them waves anyway. So as I've pointed out 4 million times, there's no wave in the Schrodinger equation. All right, so all it's telling you is the shape of the probability distribution could be any shape. There's lots of, it can be a straight line going this way, it can be a line going this way, it can be lots of lines. All right, it doesn't have to be this kind of line. It doesn't have to be a bell curve. It can be a frog curve. It can be a platypus curve. It can be a lot of different kinds of curves.
We're going to use the word wave, but it's not a wave. It's the same thing that you do with spin, right?
Yeah.
It's not spin. Nothing's spinning, but we're going to use the word spin, and we're just going to go with that.
Very, very.
Yeah, right. So, and he doesn't have an answer to that. He doesn't say, well, yeah, I know that's really fucked up and retarded, and we should really do something about that. No, he'll just keep doing the same thing.
Very simple solutions to Schrodinger's equation do look like waves, but it's not universal.
Sure.
But
It's not universal for physics. Does it even matter?
That's fair complaint. So they're described by waves, but what's really going on is, like you said, it's a probability thing. So the solutions.
So it's a probability thing, which is again back to this simple argument that they're taking a system and they're assuming the system is really, really stupid. So it's a school of fish. They see the school of fish move 2 miles an hour in a direction, and they just sit there and say, all the fish are doing this. They're all going 2 miles an hour. It's that kind of a simple mistake, that you can't make these stupid generalizations. Each little bit's doing a different thing, and the thing it's doing is different based on some elemental circumstance that gives it a range of, a degree of freedom. And the degree of freedom is just how well you go through the door, right? You're going through a door. The door is smaller than you are. You know, which way do you turn? How do you turn? Do you hit the door? Does any part of you hit the door? There's lots of different ways you get through that door. Okay? They're not all going to be the same. Especially the faster I require you to do it, so the less you can the less probable. But again, if I did this, if I took a statistical analysis of how people get through the door, I'll see that, well, most of them that got through successfully without hitting anything first turned because they're thinner than they were wide. You know, but that wouldn't even work as a generalization, right? Because there's a lot of people who are wider than they are. I mean, they're fat. So they can't go sideways. But that's all it is. It's just saying, okay, I can do the experiment and there'll be an outcome in terms of what will happen. But every single individual instance is different. They're not all going to be exactly the same. There's not some dumb average and you just make the average everybody, because everybody won't be the average.
Are what we call probability distributions.
Right.
And so they're just...
I'm nodding like I'm like, yes, probability distributions. I understand what that is.
Right.
No, these are words that I know what they mean, but I don't know what they mean together in this context.
Yeah.
Just so we're...
So I like the way, I mean, she's pretty articulate and she put that pretty well. Okay, I know what the words mean, but I don't know what you're saying when you say probability distribution. Yeah, I can understand that an experiment has outcomes, and the outcomes have variance in them. And that I could understand. You could call that a probability. And it's really going to be dependent on what's on the dice, right? I mean, I can be certain of one thing. 13 isn't coming up on the dice. Okay, the 2 dice aren't going to make 13, so I know that's not going to happen. But I know there's variation about what the other numbers can be. And the fact that there's, 3 and 4, lots of ways to make a 7. There's lots of ways to make these different numbers.
All clear on this.
So the probability distributions, now those distributions, they can be distributed over lots of different properties, but usually it's across space, like position, location, that sort of thing. So you get maps like atomic orbitals and stuff, the things you usually see when we talk about.
Right, and those you haven't proven to be in any way accurate or meaningful, and beyond just saying that, well, atoms are always in complex environments. No 2 atoms are in exactly the same environment, so no 2 atoms are going to be exactly the same shape and exactly the same blah, blah, blah. And especially when we're looking at them, well, then they're really not going to be in their natural environment, right? We put them under the microscope, they're not exactly at home.
Probability of an electron.
As long as we're not observing it.
Well, we're going to get to that.
Okay.
No, as long as we're not trying to figure out where it is and fucking up where it is by trying to see where it is. I mean, obviously we can't see where it is. We can't. It's not possible. Because to see where it is, we have to move it somewhere else.
This is going to be very important for today's topic.
Okay.
When we have this wave model that describes how a particle exists or how it's behaving or how it's going to behave, we often say that the particle could be in multiple states simultaneously, which is is a gross misinterpretation or misrepresentation of what quantum mechanics actually says, which, we'll probably get to in a future video. It's just that the states of these particles, they don't exist like normal things exist.
Welcome to quantum mechanics.
Yeah, I mean, so that's supposed to make sense to somebody. Okay, they don't exist as things exist. So everything is open now. So how many rules can I break for normal? All right. So it doesn't have a place, and it's not in a time, and it's not this, and it's not that, and it's just magical stories. So that's physics. Modern physics is just a magical story about magical things. It just doesn't have anything at all to do with anything, any notion of finding out whether they can demonstrate a simple answer. It's all about, can we tell, how wacky can our story get? And they might as well start introducing the homunculus, right? The brain inside your brain, telling your brain what to do. They're probably going to come eventually to a god. Okay, they'll find their god particle because they're heading right for it.
Right.
Here we are.
And so things are just weird. They're weird.
I'm sure it can be difficult to understand and explain to the normal population that only has normal science to work with. You know what I mean? If things don't exist the way that we expect them to exist.
So what they're really doing is, in a way, is they're taking something formal like mathematics and making it ambiguous. It's a contradiction in function. So that's why it's all broken.
I'm sure that's very confusing for the rest of us.
Right. So we say this particle exists in a superposition of states.
Mm-hmm.
But that superposition is one state. It's not multiple states. It is one existence for that particle.
It doesn't have you're denying your own principle. It doesn't have any existence because it can't be allowed to be real in any of the possibilities. So in no possibility can it be real. So in none of the possibilities or probabilities can it be real, because then it can't be free to be in all these other places. So it's just such horseshit language. It's real, but it's not real. I mean, how does that make sense to anybody?
It's just that existence doesn't make classical sense, right? It's that superposition is a combination of multiple classical states, the kind of states that we expect a ball to be in.
I mean, I feel like you're really splitting hairs, though, to say that, it's not existing in multiple states at the same time. It is existing in one state that is all of the states at the same time. I mean...
Yeah, see, so again, clever. I mean, she put that well, so very smart. So she has thought about this. And yeah, she's thought about it and said, shit, I'm glad I'm a biologist. Because I'd really hate to have to defend this horse shit.
Right. Well, it's a real, actual single state that is a combination of physics states that we would understand relativity and quantum.
So again, that was just horse shit, right? I mean, it's not an equation. It's something you should be able to draw. So you're basically saying there's an ambiguity in what it is. So you're saying it has some kind of ambiguity. It's not making gravity. It's not being affected by gravity. It's not interacting with atoms in the environment. It's not doing any of these things, because if it does any of those things, then it can't be in all these other places, and it can't have those as options. And that's just plain ridiculous.
Mechanics.
Mm-hmm.
But what quantum mechanics has shown us is that there are other single states that exist that we don't understand.
Okay. So not even talking about superpositions, or we are. That is what we're talking about.
A superposition is a single state that just doesn't make sense to our brain.
So there's no point in calling it a single state, because it's not one of the available states. It's like saying there's a multiverse, okay? We're going to create a new universe depending on where we are. Well, we can't be somewhere and then be making all of those universes or be in all of those universes. So that's not possible. So it's something in a state of not being in any state, which is just stupid.
Is it like 4 dimensions, if you will? How we get 3 dimensions when we start talking about higher dimensions? We just really struggle with understanding what that's like and how that works.
Yeah.
Yeah, it can't work because the rules for a dimension are you're at a right angle to the other 2 dimensions. So the 4th dimension would have to be at right angles to all 3 of the existing dimensions. And guess what? Nothing can do that. So it's just plain stupid to call it a dimension because it can't exist. So again, they just break physics to make physics. It just doesn't make any... There's no rules. So we haven't figured out anything. We didn't figure that out. We didn't draw the 3-dimensional lines and say, what do these lines all have in common? Oh, they're all at right angles to each other. Gee, that's a really important feature. Every single one of the dimensions makes right angles. Gee, that's the rule, it seems. That's what makes it dimensionally. You know, that's where it gets its dimensionality from, is obeying obeying that rule. Ugh. And now we're just going to say, fuck it. Fuck the rule, fuck the property, fuck making sense. We're just going to use the word dimension to mean any old thing we draw. Any bizarre notion of, well, it's almost a right angle, or it's what? There's nowhere to put it. You can't do it. It just doesn't fit. It's just wrong. It's like, it's like breeding rabbits with parameciums or something. It just can't work.
That's exactly it. So these particles exist in a way that violates our intuitions.
Mm-hmm.
Oh, it's not violating an intuition. It's violating sense. Reasonable, rational sense. It doesn't make any sense. It's contradictory. It's principle violating. It's completely antithetical to logic. It doesn't make any sense.
There's one major problem, and it's called the measurement problem.
Okay.
Quantum particles can behave in a couple different ways.
Okay.
There's a very nice, steady, controlled way, which is when the waveform evolves over time. It changes over time very gradually according to something like Schrodinger's equation.
Right, so again, just understand this is group behavior equation. It has absolutely nothing to do with the individual particle and what the individual particle is going to do. So it's nothing to do with anything that's individual or understanding that each bit of the outcome is made out of these discrete events taking place. Trillions of these discrete events happen, and that produces the outcome. And so this equation, again, is just trying to say, I'm going to talk about the individuals by analyzing the group. And that's dumb physics. You have your cart on the wrong side of the horses.
Other possibility is we take a measurement. Now, the word measurement has some ambiguity to it.
Okay.
It seems to imply a person needs to be involved and there needs to be an experiment, which is not necessarily true.
It's not at all true. So he says it's not necessarily true. No, it's not at all true. It's absolutely zero truth value to any notion that a human has to be involved to create a measurement. A measurement happens whether the human initiates it or doesn't initiate it. It happens whether he intends to measure or he doesn't intend to measure. It just happens. The universe constantly is interacting with the universe.
If a person is not experimentally measuring it, then what is a measurement?
Very good question. I would say that a measurement is any particle interaction that releases information about a quantum system to this.
So releasing information isn't the only aspect, right? I mean, but clearly bending a photon is releasing information. So there's no way to say it's not information changing. So even though the photon, they would argue, technically isn't creating gravity, I guess they would argue that, even though that violates the principle also. We know that all the things making gravity are affected by gravity, so why would photons be the exception again? But clearly they're affected by it, so they're constantly being measured. I mean, there's just no theory that says gravity just stops for a while and then it turns on and then it turns off and then it turns on and it turns off. Their bent space is instantaneously always on. I mean, it moves at the speed of light, but its onness is always on. It's always measuring you, theoretically, by their own theory. Gravity isn't blinking like a particle, by their theory. It doesn't have any nuance. It doesn't have any Planckness. That's why it doesn't fit with quantum mechanics.
Surrounding environment. Now, that environment might be a lab with a person in it, but it doesn't have to be.
Is this similar to, like, if a tree falls in the forest, does it make a sound type of thing? Like, it produces sound waves even if no one's there to hear it? Like, this produces information even if no one's there to gather it?
Not exactly.
No, yeah, so what is it? And he fixes it because he's arguing against that being a good analogy, but that's pretty close to the truth. They're trying to claim, okay, that somehow it's not making sounds because there's no measurement taken that we're considering a measurement. So the argument would be that the real measurement problem is that how do you avoid measurement? How can any system run any amount of time without constantly being measured? That would be the measurement problem.
Exactly. Future Nick butting in here for a minute. Her analogy about the tree making a sound is actually much better than I gave it credit for while we were filming. Now that I'm editing the video, I realize I was a bit too dismissive of it, and I wanted to point that out. Okay, back to the conversation.
Too bad they do this editing thing. Be actually good to see the actual conversation and all the conversation, but whatever.
We're trying to define a measurement like this so that quantum mechanics doesn't sound like magic, right? It's not like
Oh, it doesn't sound like it. But every feature of it is. It's God of the gaps, mushy, silly answers to questions that you should probe just a little bit harder to find the real answer. So again, they have a simple choice with the two-source radar experiment. Right? The mathematics for jamming, exactly the same. So you have a choice. You can believe that for no reason, because there's no slit to create a superposition, that the radar signals are traveling through space and somehow interacting with each other as forces. So it's like a photon bouncing off a photon somehow. Somehow a photon is interacting with another photon, which is the same as a photon interacting with magnetism or photon interacting with gravity, for example. It always comes up because it's just so out of... It's, you know, the whole idea of a photon being bent by gravity is so antithetical. You know, it's so opposite to every other reality of what forces do in the real world. There's just no other example of any piece of force or anything like a force or anything moving the speed of light that it's all affected by what all the other stuff moving the speed of light is doing. There's just no evidence that forces can affect the force, and you know, except for this one stupid example that they never proved with this, you know, and they have this garbage experiment saying it happened when it didn't happen, and they didn't repeat the experiment, even though there's 400 times better resolution from space. I mean, it's just so bad. I shouldn't have to work this hard, this aggressively to fight all of this obnoxious tension and fight through all of this harassment, this personal affronts to my right to even live as a human being, because I dare to sit there and question the authority, to question the reasonableness of this theory. It's unreasonable gibberish. I shouldn't have to explain it to you. It's so obviously bad as theory.
Beings are looking at the situation and we're like, we're going to look at this and see what it's doing, and then it changes. Like, we're not affecting the physics of the problem, right, of the experiment. It's just happening because of like the way that we're measuring it. In order to measure something about an electron, we have to do something like shoot photons at it.
Okay.
And it's the photon that's making the measurement happen, not the person.
So that measurement would happen if a person shot the photon or if the sun shot the photon.
Exactly.
Right, there you go, right? So their theory is that somehow there's any possibility that any experiment that has anything to do with this superposition crap could last any longer than a trillion gazillionth of a second. Like there's any possibility that something isn't interacting with the universe a trillion times per second. That there's no, you couldn't be superimposed for more than the briefest, tiniest bit of distance moved in space. And again, just by their own theory of gravity, gravity is an infinitely dense, bent structure. There's no way you can evade it measuring you.
Point here.
Exactly.
Okay.
As long as those circumstances took place for that electron and photon interaction, it's considered a measurement.
Okay. Again, with like using words
Yeah.
that don't mean what we think that they mean.
The problem we run into, what we call the measurement problem, is that even if a particle like an electron is in a superposition of states, a superposition state, I should say.
Right. Because it's just one state.
Right, it's just one state. If it exists in a
So she's kind of mocking it. It's just one state. That's every state. Every possible state. Well, what the fuck's a possible state? What does that even mean? 13? Is 13 possible? Oh, no, it can't be.
superposition state, if we look at it, if we try to take a measurement, we try to shoot photons at it, we will not see that superposition. We will only see a single classical state, one of the parts of the superposition.
Right. So just imagine this experiment, right? So something's moving through space, bombarded by the universe. It's being affected by gravity. It's being affected by magnetism. It's being affected by electromagnetic waves, which are magnetism essentially, right, at a frequency. It's being bombarded by all kinds of crap constantly. And now all of a sudden we're going to throw our special crap at it and measure it. And somehow we're going to be able to measure something entirely different than what all that other crap was doing to it. That somehow all the crap happening to it before our measurement photon is somehow different than our measurement photon. No, it's the same thing. I mean, there's no room for it to see, oh, it was in a superimposed state and our measurement affected it. No, our measurement is so minor an event in its life. It's so meaningless. I mean, it's one grain of sand in a gigantic beach of measurements. It can't possibly mean something special happened. So there's just no chance that it was in some previous state where no sand was hitting it. Nothing exists in this universe without being hit by the sand.
It's like it collapses.
Yes. In fact, we call it wave function collapse.
So just too silly. How did it get uncollapsed? How long a space was it in this uncollapsed form where it wasn't interacting with any sand? Is it possible to imagine there's no sand, then there's our special photon sand, and then there's no sand after? Is that a reasonable way to perceive how the universe works? Or is that completely unreasonable nonsense? That Schrodinger's cat is being measured by the cell phones, it's being measured by the machines, the transformers, it's being measured by Alpha Centauri, it's being measured all the time and can't be in any superimposed fucking state. The rest of the universe knows it's alive or dead. Okay, we just don't.
Got it.
And this is a big problem, mainly because this collapse, this wave function collapse, in order for it to make sense, it has to happen instantaneously.
So it's not a gradual.
So that's the silly part. Like they're worried about the instantaneousness of an event that has to happen in such a tiny scale of time. How could it even be a meaningful measurement? It's moving the speed of light. How could you even meaningfully measure something moving the speed of light unless your measuring device is moving even at least that fast, right? So, I mean, to even worry about instantaneous in that context is so frickin' retarded.
Shift.
Right.
Okay.
And so because it happens instantaneously, and we know from our experience with the rest of physics that nothing happens instantaneously,
Right.
that it's a major problem.
Oh, I mean, that's just so funny that they think that's the major problem. No, the major problem is that the measurement we're doing is completely irrelevant in the sea of measurements already being conducted. At the very moment we're measuring, there's already 4 million other things in the universe measuring. Again, every star in the universe is already measuring it. Every single physical object in your environment is already measuring it.
Okay. Is it a problem, or is it just the way that quantum mechanics works, and you just have to accept that this is a weird science that does not act?
So she's heard the generalizations that, oh, it's just about producing results, so we don't care how wacky the theory is. You know, as long as we can, in some general way, know that the school of fish gets to, the other side of the street. Why did the school of fish cross the road? Well, we don't fucking care as long as we know it crossed the road. That's the punchline to their joke. Or, there's a baby tied to it.
The way that you expect it to act.
That is a way that some people handle this, but not a way that everyone handles this. And so...
Which way do you handle this?
Ooh. We'll get to my personal opinion later.
Okay.
Quantum mechanics sort of brings to light a discrepancy in how people view physics.
Sure.
We like to view physics as though we're finding some deeper understanding of it.
Okay, so we would like to think that physics is about finding the truth, and it's not. Oh, okay, that's the punchline, right? So this is religion. This is like some communist plot. This is, the propagandists. We'll just want to control you. We don't want to do it in any kind of honest way, so we'll create a bunch of dishonest bullshit to control you. I mean, this is just as bad as God as a theory. Oh, it works. It keeps people from killing each other, and it makes them do nice things because they're always worried that Santa Claus is watching them. I mean, Jesus. It's just so bad. So they're admitting, Yes, our motivation is completely religious. We just want to control people. We don't want to control technology. We don't care about understanding it.
The universe. But it's not really what physics is about. Physics is about making predictions.
Okay.
Oh, it's just so silly. No, it's about accurately describing systems. And if you do that, you'll be able to predict. That's the side benefit of having the truth is, yeah, it's really predictive. Okay, but they got again. The horses are so obviously on the wrong side of this cart. I mean, it's so bad.
Right? We want to be able
All
to.
science is about making predictions, right?
Right. Well, exactly. So what we try to do in physics is we try to come up with a model that's going to predict future behaviors of things.
Okay.
Right. So in this.
Right, and so in this case, we can get away with a silly model. Yeah, the right model would work even better. Like I said, the jamming explanation works just as well as explaining, and it has the benefit of actually being the truth. Yeah, yeah. So don't bother with the true answer. We'll just use the mushy answer because it's more fun. But that's all this is about. It's more fun. It doesn't have anything to do with the truth or even function. Because I can't prove to you how badly you've ruined science and how much we didn't accomplish because you wasted everybody's time with these mushy stories.
Case quantum mechanics is predicting future behaviors of quantums or little quantum particles.
Right. Okay. It allows us.
And those predictions could be made without quantum mechanics. So that's the simple explanation is we already know systems have probabilities. It's not, we don't need quantum mechanics to clue us in. We can understand that, and we don't have to understand it as an uncaused event, as Richard Feynman would put it. We don't have to do that at all. There's no reason to do it. No good reason.
Us to make accurate predictions.
Correct.
Using this branch of science.
Right. All right. I'm going to stop the conversation there before this.
So again, jamming predicts. Okay, the jamming model predicts outcomes, and they're exactly the same outcomes. So let's not pretend that quantum mechanics predicts better or does any of that. No, it's not better. Doesn't do it better. They're just choosing the wacky answer.
Turns into a 45-minute video. If you want to hear us chat about interpretations of quantum mechanics, let us know in the comments.
Well, that's a real wasted time because the interpretations are all based on a silly axiom that somehow there is something to explain. Something wooey is going on. And so why interpret a wooey explanation? So if you get the mechanics right, then you don't have to worry about your interpretation. Okay, because the mechanics tell you what it's doing. I don't have to interpret it. Anyway, so bad. And the rest is just brilliant, commercials, blah, blah, blah. So I'll spare you that. Ugh. So, again, I don't even understand. I guess I'd like to think I was smart enough, to be able to measure or to understand human behavior, and I was just wrong. I mean, I thought people were just deceived, but they seem to be fundamentally attracted to being deceived, Like I was thinking they were being fooled by a fooler. But their nature is to be a fool. They're naturally foolish. It's not like they have a religion gene, but there is obviously something fundamentally broken, mongoloid or something, about what happened to humans. And as an organism, our capacity to do reasoning, to figure out that I can't walk through a tree, I got to walk around the tree, to do logic, that somewhere that got broken. And now people are walking through trees. I mean, they're just doing illogical things with facts. They're mixing them in ways that make no sense. And I'm just trying to say I really overestimated your intelligence. I thought people like this guy and other people, I'd say, well, if you reasoned with them, they'd get it and they'd say, oh yeah, we fucked up so bad. We got to fix this. I mean, we can't keep saying things that are just not true, because it's deceptive and it's nonsensical. We can't talk about concepts that have grotesque contradictions in them. and as if it's not contradictory. We can't pretend that some invention like dark matter isn't just a desperate God of the gaps reach for an answer. I mean, completely unevidenced, nonsensical, gremlin answer. I mean, it doesn't even come close to having any truth value. It's so disconnected from any evidence and disconnected from any physically probabilistic or realistic expectation. That the universe is full of some special matter that can't be detected except that it makes gravity. I mean, it's a silly proposition, and they don't admit it. That it shouldn't really be taken seriously at all as an idea. It's so distant from anything you could call evidence. But anyway, just horrible. But yeah, so your people suck a lot worse than I thought. I mean, I knew people were flawed and not so great, but no, you're profoundly shitty. Yuck. Yeah. More reason to hate this planet, unfortunately. Ugh, God. Yuck. Yeah, there's no other response. Yuck.